Hey guys, let's discuss a new design question from system design, which is called AI powered notification system design. So here we will be designing notification system which would be AI powered. Okay, so the problem statement is design a system that send notification and use AI into it, and send notification, so you can send in multiple ways. So like push notification means let's say user is offline, okay, your screen is locked, but still you see the notification. Okay, so that kind of notification called push notification. Then we can send notification through email also, and through SMS also, and through in-app also. In-app means when user is offline, okay, logged out, that time we will send it in app, and when user will log in, he can see the notification. Now uses AI to so we will use AI here to decide who to notify, when to notify, and what content to send. Okay, so for example, in Facebook, you see the notification, you have memories to look back. Okay, or in Amazon you see the notification, price dropped on item you viewed, or Netflix new episode available. So all these things are achieved by this notification system. So in AI powered notification system, push means push notification, message sent from server directly to the user's device even when the app is not open. Okay, so example, you get the notification your order is delivered, new video uploaded, these appears on your lock screen or the notification bar. So now that is push notification. So simple difference, if you talk about push and pull. So push is server pushes message to user, and pull, so user open app and check manually the message, and then only it will get load. Now high level architecture, if you see here, so high level architecture is see, event producer will produce the event. Okay, means it could be your application, it could be your services, like user clicked on this page, user viewed this product, so all these things are events. Okay, and it will generate billions of events. Then you will have the one queue, so these all events will go to that queue. This queue will connected with the notification service. Notification service will use user profile to get the user detail. AI engine will decide what to send, who to send, when to send. Okay, and then template engine will use the templates and will send all these things to delivery service, and delivery service will send the message to the user, okay, and users. Now what are the core components? So whatever we just discussed is the core component. So for example, event producer trigger events like order placed, new message, price dropped, friend request. Okay, these all are the events. So event producer will trigger these events. Example, user viewed product, event generated, one event generated when you see the product. Message queue, so we use Apache Kafka or Apache Pulsar. And why? So for decoupling. Okay, so let's say you know the concept of synchronized services and asynchronized call, right? So in synchronized call, each call means each service call will happen once the previous service call will end. Okay, and in asynchronous, what you will do, you will call the service, and then you just and then that thread will continue working, right? And then parallelly that the another thread will start, and then it will execute the task. So the same thing, decoupling. So here you have decoupled the task, right? Because let's say order created, but now delivery service, notification service, they can work parallelly. You don't need to wait user to send the to get the response, right? So that is how we decouple it. And high throughput, of course it is means you're doing everything parallelly. Okay, and then retry capabilities, so you can retry also if that gets failed event. Now notification service, so notification service is a core brain here. Okay, so filter service applies rules and call AI engine. So now let's discuss all these three things. What are these three things? Okay, so see, in notification service, these steps decide who should receive a notification and whether it should be sent at all. Okay, so that is how you decide. So now let's talk about the first thing, which is filter event. Okay, this one. So filter event ignore unnecessary events. Before sending notification, the system receives many events, okay, but not all should trigger notification. So for example, user liked your post, okay, or user viewed your profile. And the third one is user commented on your post, so you get the notification for comment and not for the like and view. Okay, when you log in the app, then only you will get you can see that. So you may only notify for comments, not views. So filtering becomes input events, like so here input events was like, view and comment, but what is the filter event? That one is comment only. Okay, so real world example, Instagram does not notify every profile view. Okay, and then but it does notify when someone comment. That's event filtering. Now second one is apply rule. So what is apply rule? Decide condition for sending notification. Okay, when to send. After filtering, rules decide how and when to notify. So for example, only notify if user is offline, only notify high priority messages, do not send more than 5 notification per hour. Okay, you're limiting the notification there. Send only during daytime, nighttime don't disturb user. Example scenario, example scenario, you have events like new message received. Okay, so what will be the rule there? If user is online, show in app. Okay, don't show in the notification bar or on mobile screen. If user is offline, then send push notification. Okay, when your screen is locked, you see the message or on a notification bar. If nighttime, delay notification. Okay, and then the system decides accordingly. Now third one is the next component is AI engine. So this is what makes system next level. Okay, so AI responsibilities are here. User targeting. Okay, so who should receive notification and how he will target it, like past behavior. Okay, and then click history, engagement pattern. So all these things he will take as an input and then will decide. Send time optimization. So now what is STO here? Best time to notify user. Okay, what will be the best time? So let's say user opens app mostly at 9 p.m. Okay, so he will send notification at 8:55. So he will check the user, he will read the user behavior, user pattern. Okay, when he is logging to the system. Now content personalization, so generate smart messages. Example, instead of sale is live, okay, AI will generate your favorite shoe are on now 30% off, because he knows that user clicked on that shoe. He saw the detail of that shoe. So this kind of smart notification he will send. Now notification frequency control. Avoid spamming. Okay, definitely user will get frustrated. So AI decides maximum notification per day per user. Models used. So now here we are using ML models. Okay, so like for example, we are using classification model, so which will decide will user click on this link or not. Okay, if you send the notification. Then ranking model, and then reinforcement learning model. So let's discuss one by one all the models. Okay, but before that, you have another component which is template engine. Okay, so dynamic template. Example, so hi, and then the username, price dropped for particular product. So dynamic template we will be using here instead of a static one, which we were generally stored in the database and then it was fetching the value and just putting the value. No, now that is not the case. Here we will use AI and it will generate the dynamic model. Now input delivery service. So here you can, as we discussed, that we'll send a notification to user via push notification, where we use the Firebase, email or SMS. Okay, now data flow example. So data flow example, let's say price drop notification we are talking here. Okay, scenario, so user view the product on Amazon. Okay, price drops, so event generated, okay, that this price is dropped for this product. So event goes to Apache Kafka, notification service consumes it. Okay, then AI engine check will user click or best time, then template generated and notification sign. So this is the normal data flow. Now AI feature. Okay, so here we will talk about that models which we just I told you, right? We will discuss it now. So the first one is ranking model. Okay, then second is reinforcement learning loop we have here, and then feedback signal. So let's discuss about first this feedback signals, and then we will come to this ranking model and reinforcement learning loop. What is that? Okay, so let's talk about feedback signal. The first one is CTR, then open rate and conversion rate. What are these metrics. So these are metrics AI uses to understand if notifications are working or not. Okay, they act as feedback signal to improve future notification, as this is the reinforcement model, right? Because it will learn again and again and then will improve itself. So now the first one is click through rate, CTR. So CTR is how many users clicked the notification. You send 100 notification, 20 user click, 80 ignores. So what will be the CTR rate? 20 divided by 100, 20%. What it means, notification is moderately interesting. Okay, so real example, if we see YouTube send new system design video uploaded. Okay, this notification. Now if many people click on it, then we can say that it has a high CTR. Otherwise low CTR, and AI learns what title work better. Okay, now the second one is open rate. So means that how many users open the notification. Okay, this is slightly different. User tabs notification, and app open the notification. Okay, so example, send 100 push notification, 60 users see notification, 30 open it. So what is the open rate? 30%. This tells is notification attention grabbing or not. Okay, so for example, Instagram notification, someone liked your post. Definitely, usually it will have a high open rate. Everybody wanted to see who liked the photos or post, right? Now conversion rate. So third one is the conversion means did user completed the goal after clicking. So it means that goal could be buy product, watch video, book ticket, and place order. Okay, there would be always one goal for which we are sending the notification, right? So our end goal should meet. So what the example, if you check, so send the send sale notification. Okay, 100 user received that notification, 30 clicked on it, and 5 purchased. So what would be the conversion rate? 5%. Okay, so notification interesting, good CTR, and but not convincing enough to buy, low conversion. Okay, now full flow example, if you check, okay, from Amazon, notification is headphones 50% off. So 1000 user got that notification, 200 clicked on that, so CTR would be 20%, and 150 opened that. So it means that open rate would be 15%, and 40 purchased, so conversion rate would be 4%. So AI uses this to improve next notification. In one line, if you wanted to say, so CTR, did user click it? Open rate, did user open it, open app? Then conversion, did user completed the action? Now let's talk about ranking model. So AI scores each notification and send the highest score first, because see, you cannot bombard user with the notifications. Okay, we will be having one limit to send the notification, that per week we will be sending 5 notification to this user. Okay, so AI will decide the notification score, and top notifications we will send to user. The formula looks something like this: score equal to f of user interest, recency, and then price sensitivity. So what is user interest? Does the user like the topic? Okay, like this topic. Recency means is this new or recent? Price sensitivity, does the price match user's budget? Okay, so for example, user behavior is something like this: he likes the electronics, he recently searched for headphones. Okay, usually buys under 2000 rupees headphone. So what notification generated for him is headphone 1500 rupees, shoes 5000, old laptop deal 3 days old. Okay, now here AI will give the ranking to these notifications. So the highest ranking would be given to the this one, high interest, recent, and affordable. Okay, and then second ranking would be given to not interested, low score, and third ranking would be given to old deal or medium score. So AI sent headphone 1500 first, and then later other notifications. Now second one is reinforcement learning loop here. So this means AI learns from user action and improves continuously. Okay, so flow will be send notification, user will take action, and then model update himself. So for example, send notification 50% off on headphone. What user can do? Either he can click or he can ignore, right? So model update, if clicked, then AI learns user click headphone still. If ignored, then AI reduces similar notifications. So continuous learning loop will be, first you send the notification, user click on that, so AI will learn, he will improve himself, and then send better next time. Now real world example, if you see, so Amazon, Flipkart, YouTube, there they're liking this notification thing, and then they constantly track your clicks where you are clicking on the app, tracks your ignores if you're ignoring that message, okay, and then improve recommendations. So on basis of that, you will get the next notifications. Database design, if you talk here, so database design, we will be having one user table which will have the fields user ID, preferences, time zone. Second, notification table, so notification ID, user ID, content, and status. After that, events, event ID, type, and timestamp. So you can store all these informations here in this in these tables. Now let's talk about key trade-offs here. Okay, so let's discuss these four key trade-offs in detail. So the first one is, see, these are system design trade-offs. So what is trade-offs? Meaning, if you choose one thing, you sacrifice another thing. Okay, if notification system, you cannot optimize everything at once. So let's break each one with simple examples. So first one is batch versus real time, and you can say latency versus cost also. So see, batch send a notification in a group. Now if you are sending notification in a group, what would be the thing? See, it would be cheaper. You're not sending one by one. It would be cheaper. It will use less bandwidth and all, right? But at the same time, it would be slow also. Now for real time notification, so you will send it immediately, and this one will be fast also, but it would be expensive. So now example, if you take Amazon sale alerts, okay, you send this notification to every hour to the user, but if you have a price drop notification, you have to send him immediately, okay, because the price will again get increased, or the inventory will be out of stock. So what would be the trade-off here? If you go with real time, then it would be low latency and high cost. If you go with batch, then it would be high latency but low cost. Okay, the second trade-off is AI versus rules, or you can say accuracy versus complexity. See, the rules are simple if conditions, so this is easy, okay, but less smart. AI rules are learns from user behavior, okay, so this would be accurate, but it would be complex again at the same time. So example is rules. If you see, if price is less than 1000, so send notification. That is the rule, okay. So AI learns user likes electronics, and then he will learn that user active at night and send smarter notification. So what would be the trade-off here? See, rules are simple and fast, but AI is accurate but harder to build and maintain. We all know that, right? Now third one is push versus pull. So you can say freshness versus scalability also, right? Push means system send automatically. Pull means user check manually in the app when he refresh, so he will get that. Gmail push notification, so that is instant email alerts, right? And pull, so user opens app and refreshes inbox. So if you talk about trade-off here, push is fresh, update but heavy load, and pull is scalable but not instant. Scalable means you can send so many emails at the same time to the user, right? Personalization, fourth one is personalization. Better UX versus compute cost. So personalized notification improves user experience, that is true, but requires heavy AI computation also in the background. Example, Netflix recommended based on your taste, okay. Each user gets a different notification. So what would be the trade-off here? See, personalization, user loves it, but expensive ML models and infrastructure, okay. So if you talk about scaling consideration here, you can horizontally scale the system, okay, based on user ID. You can partition, you will create a partition here. So I have created a system design, core system design video on Kafka very nicely, and you can go and check what all this partition and all I have explained in detail. Okay, second is rate limiting. I've created video on rate limiting as well. So rate limiting will prevent spam here. Retry mechanism, so exponential backoff. So what is exponential backoff here? See, retrying a failed operation with increasing wait time after each failure. So you're retrying one API, let's say, okay, it got failed. So instead of retrying again, okay, you just add some delay in each retry thing. So for example, first time you retry, it got failed, so you will add delay of one let's say 1 second. Then again retry, it got failed for 2 seconds, then again it got failed, then 4 seconds, then 8 seconds, something like this. Okay, so exponential growth in the delay time. Now challenges, if you talk about challenges of this system, the first one will be notification spam. Means we can send lots of notification to the user, lots of notification will get generated, right? So what would be the solution here? You just apply AI frequency cap there, that only this is the frequency. Okay, send 5 notification to each user. Cold start problem. So first time if user has logged in, he has created the account, so what we will show him on the home page. So use the global trend, global pattern. Okay, there whatever is in trend, just show him that. Then real-time personalization. So solution cache user feature. See, if you wanted to do real-time personalization, every time you, system has to go to DB and hit the DB and then get the detail. Okay, so instead of hitting DB, just cache this user feature, right? And store user free preferences and fast memory for instant personalization. Real world system who is using this notification services is system is Facebook, Amazon, Netflix. So Facebook is using engagement notification, Amazon is using transactional and marketing, Netflix is using personalized recommendations here. Okay, now add-ons, if you talk about, so see smart notification ranking. Okay, so only send top n notification to the user. Second is multi-armed bandit. So try different messages and learn best. So AI will send him different types of notifications, diversity in notification, and then he will find which one was working best. Now context aware notification. So on basis of location, device and time based, send the notification, right? So you can say that an AI powered notification system uses event driven architecture, because we are using here Kafka, right? With a streaming platform like Kafka, applies ML model for what? For targeting, timing, personalization, and delivering notification via multiple channels while optimizing user engagement and avoiding spams. So just take one example here. Imagine you open Amazon Delhi at night and you like the shoes. Okay, AI learn that time is 9 p.m. and interest is shoes. Okay, so what notification you will get? Price drop on shoes you will, only for you. Okay, so that's it. Thank you.